the second normal form, or you can say 2NF. So in the second normal form we have two criteria. Number one, the relation should be in 1NF, or you can say it should be in 1NF. And second is, we do not allow partial functional dependency. Okay, see, this partial functional dependency, this line can be written in several ways, like this: no known prime attribute. See, there are several ways of representing the same line. If you read the different textbooks, whether you're reading Korth, you're reading Navathe, or you're reading any other local author, you'll be seeing that they are writing a different lines, right? And all the lines mean that we do not allow partial functional dependency. So here, instead of this, you could also have written as no non-prime attribute. No non-prime attribute is dependent on any proper subset of any candidate key of the table. Okay, or it can also be, it can also be written as the relation is in 2NF because it is based on fully functional dependency, and we do not allow partial functional dependencies. So we can also write it like this: 2NF is based on a relation schema R is in 2NF if every non-key attribute of R is fully functionally dependent on the key attribute of R. So you can also say that relation is in 2NF if every non-key attribute of the relation R is fully functionally dependent on the key of R, right? So then the relation is called as 2NF. It is in 2NF. Okay, so for example, let us take a very simple example here. Assuming that we have a relation R A, B, C, D, and the functional dependencies which are given, they are AB determines C and B determines D. These are the functional dependencies which are given. Now there are two ways. Number one, find what is if you want to find whether the relation is in 2NF or not, find what is the primary key of this relation, or you can say find what is the candidate key of this relation. So in the candidate key, you can see on the right hand side we do not have two attributes, that is A and B. So every candidate key should contain AB. So if we take AB closure, then you can see I am getting A, B, C and D. So because of AB we are getting C, and because of B we are getting D. Okay, but when I'm saying the relation should be in 2NF, that means any subset of this key should not determine any non-prime attribute, right? So here, what are the prime attributes? Attribute A and B, they are the prime attributes. Now if this is the candidate key, then any prime attribute should not determine any non-prime attribute, right? But here you can clearly see B is a prime attribute, but B is determining D. Now because of this functional dependency, the relation is not in 2NF. Right? Now if you want to convert this relation to 2NF, that means we have to break, or we have to remove this functional dependency, and to remove this functional dependency we have to break the relation, and to break the relation we have to see what will be the decomposition where the relation can be in lossless, right? So the relation can be lossless, as well as the relation should be functional dependency preserving. Okay, so here you can see the relation R is A, B, C, D. Now we know that the relation is not in 2NF because of this functional dependency B. So if you take B closure, then you will be able to get BD, but if you take A closure, then you will be able to get only A. Okay, so because of this B closure, because of this B is a prime attribute, the relation is not in 2NF. So we have to make another table with these attributes, that means the attributes which are coming in B closure. So we will be making a table with BD and the other table will be containing the attributes which are A, B and C, because B took D and B should be it should be a common attribute in at least in both the tables, and it should be a key attribute in at least one of the table to make it a lossless decomposition. Now we are getting two tables here. For this table, the functional dependencies which are possible as AB determine C, and for this table the functional dependency which is possible is B determine D. Now you can clearly see this decomposition is FD preserving. This decomposition FD preserving, as well as this decomposition is lossless. Okay, so in case of 2NF, we'll always get a lossless decomposition as FD preserving decomposition. So we'll be taking more examples of 2NF, and we'll be trying to see if a given relation is in 2NF or not, and if it is not in 2NF, then we'll try to convert that given relation into 2NF. Okay, right now just understand that here the relation RABC was not in 2NF because of this functional dependency. To remove this functional dependency, we decomposed this table. We decomposed this table into two tables, and we want these two tables to be lossless. To make it lossless, that attribute because of which we are getting this problem, so we made that key attribute in at least one of the table, and in both these tables we are getting some functional dependencies, and it made it functional dependency preserving. Okay, now let us see more examples on 2NF.